So we are looking at carbohydrates and specifically monosaccharides. Now the first thing we need to understand what are carbohydrates. So just from the word carbohydrates, you can see in the word carbohydrates we've got carbo and then hydrate. So carbohydrates are simply hydrates of carbon. Now what are hydrates? Hydrates are organic compounds which contain water in them. In other words, the functional group for water, or they contain H2O. So when you're talking about carbohydrates, these are hydrates of carbon, meaning they are compounds which contain this group in them and then they're made up of carbon. So those are what we call carbohydrates, hydrates of carbon. Now the general formula for carbohydrates is CnH2O and then N. This is why we are saying they're hydrates of carbon because they contain the water in them. Okay. Now carbohydrates can either be aldehydes or ketones. So for you to be able to understand what are aldehydes and ketones, you need to know that aldehydes, these are organic compounds which contain the functional group at the end of the chain. And then these ketones contain the functional groups on the middle of the chain. Now, again, we need to know what a functional group is. So don't worry about that. I'm going to talk about it. Okay, so basically just know that we have got for carbohydrates, we've got ketones and aldehydes. And then from here, let's understand. We are saying carbohydrates, we've got that formula that we've written, which is CnH2O(N). This N is just representing the number of carbons. Now we want to look at monosaccharides so that we can be able to classify these carbohydrates according to the number of carbons. So when you talk about monosaccharides, this is just the simplest form of a carbohydrate. So if they ask what is a monosaccharide, it's a simplest form of a carbohydrate. It is made up of only simple sugar units called monomers. So monosaccharides are the simplest form of a sugar which are made up of sugar units which we call what? Monomers. Now, the name of a carbohydrate or a monosaccharide is going to depend on how many carbons are there. So in this general formula that we are saying CnH2O and then N, for you to classify, you are going to classify according to the number of carbons. For example, those carbohydrates that have got N being equal to 3, those carbohydrates which have got 3 carbons, those are called trioses. Those carbohydrates that have got 4 carbons are called tetroses. Those carbohydrates with 5 carbons are called pentoses. Those carbohydrates with 6 carbons are called hexoses. And then those carbohydrates with 7 carbons are called heptoses. So in this course we'll be interested in discussing trioses, pentoses, and also hexoses, just these three. These are the ones we're interested in discussing. Okay, now having known this, we need to know what is a general function of monosaccharides. By the way, if you've got a question, be sure to ask anytime. So what is the general function of monosaccharides? So monosaccharides are direct sources of energy. when you want energy directly for use in the process of respiration, remember in the process of respiration you get to use energy so that your body is going to do functions. So when you need that energy, you can get it direct from monosaccharides. Monosaccharides, this is where you find also the glucose that we drink, and also the same sugar, that energy from sugar, which is called sucrose. We're going to understand those better. Now, when you're talking about monosaccharides, just as we've classified them as trioses, pentoses, tetroses, we need to understand each one of them at that level. So the first we're going to understand are the trioses. Remember, for the trioses, we are saying they've got how many carbons? Who can remember how many carbons do the trioses have? N is equal to what? Yes, Casey. Good. So trioses have got three carbons. That means in the general formula that we see CN H2ON, this is going to become C3 and then H2O3. This is also can be written as C3. I'll multiply this 3 by this 2. That is going to be H6 and then O3. This is the formula for all trioses when you hear of trioses. Now, the ratio of carbon and oxygen should be always in the ratio of 2 to 1. Please, this is the ratio of carbon, I mean hydrogen to oxygen, not carbon, but hydrogen to oxygen in trioses. The ratio of carbon to oxygen is 1 to 1. Okay, that is one thing that we need to know. Now, trioses have got three carbons as we have seen. Now, we have got three possible trioses, and these you need to know them by names. Well, from the formula that you've seen, C3H6O3. Remember just at grade 2 of the topic we did in organic chemistry, organic chemistry, we looked at the structures and we looked at isomers. So the formula doesn't tell you the structure of a compound. You need to draw a structure. That is what is going to lead to what is called isomerism, because we're going to have different structures for the same formula. So also just trioses, this same formula has got different structures. And you need to know there are three trioses and you need to know them by name. Basically, they are just two, but one of these two exists in many forms. So the first one you need to know of these trioses is called glyceroldehyde. And then the next one you need to know is called dihydroxyacetone. Dihydroxyacetone. The name is not difficult to know. Di just means two. Hydroxy just means that you have got this group. This is the hydroxy. Okay, so dihydroxyacetone. So these are the two. Now, you need to know that carbohydrates have got a functional group, a carbonyl functional group. If a question came in the exam, what is the functional group for carbohydrates? It's carbonyl. Don't confuse it. It is not carboxylic functional group. It is carbonyl. They can bring also carboxylic and you might be confused. So when you're talking about the carboxylic functional group, it looks like this. But the carbon we are talking about is COH. So at times they'll just bring the structure like this and like this. That's you to choose which one is the functional group for carbohydrates. Now, when you want to draw the carbonyl looks like this. There will be a carbon and then a double bond with the oxygen and then an hydrogen. But this carboxylic acid, you are saying it is a carbon, double bond with oxygen, and then you are going to see OH. So this is the difference. This is the one which is found in carbohydrates. This one is found in acids. So the one found in carbohydrates is carbonyl. Alright, I've emphasized that. So so don't get it wrong. So every time you are drawing the structure for a carbohydrate, make sure that there is a carbon in your functional group. So in this case, we have got this formula C3H6O3, meaning we have got three carbons. I'm going to put these 1, 2, 3. When you're talking about glyceraldehyde, the functional group is at the end. Remember, this is the aldehyde. And at the start, I said carbohydrates can either be aldehydes or ketones. Aldehydes have got a functional group at the very end. So, because this is a carbohydrate, we're going to put double bond with oxygen at the end and then hydrogen like that. This is a functional group, which is the carbonyl functional group. And then now make sure that all the oxygens are used up. We have got three oxygens, but we already used one. So how many are remaining? Two are remaining. So those two, one is going to be here, but it should always be attached to an hydrogen. And then another one is going to be here, but also attached to an hydrogen. And then how many hydrogens have we used up? 1, 2, 3. So how many are remaining from the 6? We are remaining with 3. So those the 3 which are remaining, we're going to put one here, and one here. You need to know that carbon, as we did as the first topic, atomic structure, carbon should always have 4 things around it, or 4 bonds. So this carbon has got 4 bonds, this carbon has got 4 bonds, and then this carbon has also 4 bonds. 1, 2, 3, then for this one. So make sure that every carbon should have 4 bonds. So this is the structure for glyceraldehyde. You need to know it. Now, as you can see, we have got these OHs, or the hydroxyls, on the right. So this one is called D-glyceraldehyde because the OHs are on the right. So if I wrote this one like this, if you see it like this, the OHs are on the left. So this is going to be called L-glyceraldehyde. This is L-glyceraldehyde. Well, you might wonder, why have I written HO instead of OH? The one which links to the carbon is the oxygen, not the hydrogen. Okay, because the hydrogen is positive, carbon is also positive, so positive things can't be together. That's why it's the oxygen which links to the carbon. Do you have a question here? Alright, so these are the two forms of glyceraldehyde. So you need to know again, what does D and L mean? We are going to talk about that just in a moment. Let me talk of dihydroxyacetone. So again, for this one, I'm going to put 3 carbons like that. Now this one is not an aldehyde, it's a ketone. Why? The functional group is on the middle, so the functional group is here. This is where we're going to say the functional group. And then now so we've already used up one oxygen, so we're going to remain with one oxygen and another oxygen this side. Then you're going to have, remember this carbon should have 4 bonds, so you need a hydrogen there, a hydrogen there. Of the hydrogens which are remaining, a hydrogen here and a hydrogen here. Well, this carbon already has 4 bonds, so you don't need any other bond. And if you can count the number of hydrogens and compare them to what is in the formula, 1, 2, 3, 4, 5, 6, they are balanced. So this carbon here, well, I said the carbonyl functional group looks like this. Looks like that. At times, even when the hydrogen is not, it will not be there. Like here, we don't have an hydrogen, but this is still a carbonyl functional group. So this is telling you a carbonyl functional group can either be a ketone or an aldehyde. In glyceraldehyde, the carbonyl functional group is aldehyde. Why is it aldehyde? Because it is at the end of the chain. This one at the end of the chain. Whereas in dihydroxyacetone, the carbonyl functional group is a ketone. Why? Because it is on the middle of the chain. Any question here? Any question? Any question? All right. When you get a question, don't be shy to ask. Now, we've talked about D-glyceraldehyde and L-glyceraldehyde. I'm going to draw that again. We have got a carbon here, a carbon here, a carbon here. We have got double bond with oxygen and then H. Then we have got OH. We've got OH, and then H, H, and H. Now, in organic chemistry mostly and even biology, we might not write always like this. You are going to see we've just put like this, just a line, and then at the end I'm going to put this, and then also this. At every point on a line where you see like there is a T or something, then it means there is a carbon. So we again have this carbon. So where there is that carbon, I'm going to put this. I'm going to put OH and H. This means that there is a carbon also here. And then I'm also going to put like this, so that I put the OH here, I put the H here, I put the H here. At every point you see a cross, there is a carbon. So meaning we have got three carbon. This is another way that we are going to see we've represented organic compounds, so you shouldn't be surprised. Instead of writing showing the carbons, and basically if you come in the actual organic chemistry, we don't even show the hydrogens when you are using this. Is called the skeletal formula. You will not even use the hydrogen, so you might just see it like this. I'll just put that the hydrogen, I'll not show it, and then I'll just show the OH here, and then I'm also going to show the OH here. As long as you can see an hydrogen, just make sure that you balance. For example, you know that there is a carbon here, and the carbon is supposed to have 4 bonds, and you only have 2 bonds, meaning there are 2 hydrogens here. And then also here, it means there's a carbon, but you have got 1, 2, 3 bonds. It means there's 1 hydrogen, so that's how you tell. But in biology, you'll not see it written like this unless when you come to organic chemistry. Otherwise, in biology, they're going to show it like this. Do you have a question? Any question? Okay. So we are talking of the, like, we have got isomers as you saw on D glucose, I mean D glyceraldehyde and L glyceraldehyde. Now let's look at the types of isomers. We basically have 3 types of isomers that we need to know at least at this level. The first one, these are called structural isomers, and then we have got what is called optical isomers, and then we have got stereo isomers. When it comes to structural isomers, these are just compounds which have got the same formula, like the same formula but different structures. For example, we've looked at glyceraldehyde and also dihydroxyacetone. So these two have got the same formula, H6O3, but what they have different is their structures. You saw that this one is a ketone, and then this one is an aldehyde. but they've got the same formula, so they are structural isomers of each other. Now, when we come to optical isomers are isomers which tend plane polarized light. Plane polarized light, either to the left or to the right. When you're talking of plane polarized, you can think of goggles. When someone is putting on goggles, or just let's say specs, the light that is going to enter them is the goggles is going to be polarized, meaning it is going to be deflected. It will turn. So the light can either turn to the left or to the right. When the light turns to the left, that is what we call L isomer. When it turns to the right, that is what isomer. So this is where now you saw L glyceroldehyde and D glyceroldehyde. So those are what? Optical isomers. Now you need to know that it is the D isomer which is common in nature. The L is not common. Or if that came as an exam, you've heard the D isomer is more common than the L isomer. When you talk of stereo isomers, these are just isomers that have got the same structural formula, but they only differ in arrangement in space. Now, when it comes to arrangement in space, we are going to talk about that later. But for here, just know that that is what we have: optical, structural, stereo. The stereo isomers, I'm going to talk about them when we reach to pentoses. At this point, the question. Any question?
Can you repeat on the optical isomers?
Okay, optical isomers have to do with the rotation of light. So, for example, we have got this one, OH, OH, and then we've got H here, we've got H here, we've got H here, and then we've got another one. Okay, we have got these two. So both of these are called glyceroldehydes. If you see this one, the OHs are on the right. The OHs are on the right. This is going to be called D-glyceroldehyde. So it is a D isomer. And then for this one, the OHs are on the left. So this is going to be called L-glyceroldehyde. That is because this one is going to turn plane polarized light to the left. This one, it turns light to the right when light passes through